With 11 and 12, we're told that f is a twice differentiable function, f prime is negative, f double prime is positive. So this is along the same lines as what's going on with part C from number 10. We're also told that f of 3 is 4 and f of 4 is 1. We have to give a possible value for f of 5. Well, let's look at the clues. For starters, f prime is negative. That means our function is decreasing, which makes sense because our function was at 4 and it dropped to 1. We know that our next value must be less than 1 because our function is decreasing. However, we also know, actually let me write that in, decreasing. We also know that the second derivative is positive. That means that the change must be increasing. Okay. So, where does that leave us as a value for f of 5? Well, what was the change when we went from 3 to 4? When x was 3, the function was 4. When x was 4, the function was 1. Our change was minus 3. We know it has to be negative because it's a decreasing function. Our next change has to be negative 2, negative as well, I should say, but it has to be larger, it has to increase, it has to be larger than negative 3. So the change could be negative 2, the change could be negative 1. The change can't be 0 because since our function is decreasing, we need a negative change. So let's just say negative, let's take away 2 more. If we take away 2 more, that means f of 5 would be equal to 1 minus 2, or negative 1. And in fact, as long the answers that would not be good, we cannot have f of 5 be equal to negative 2. That would not work because that meant that the change did not change. We subtracted 3 to get to here, and then we would subtract 3 again to get there. That would not be good. That does not have increasing change. So negative 2 is not a possible answer. Okay. Additionally, as I mentioned a moment ago, our change has to be negative. So we cannot have f of 5 be equal to 1 because that would mean that we had no change whatsoever. But in fact, any number between those would be acceptable, including the negative 1. Oops, I wrote this backwards. There we go. Negative 2 less than x is less than 1. Any number in between negative 2 and 1, for example, negative 1, that would be okay. With number 12, same thing, except this time h prime is negative and h double prime is negative. So we have, once again, a decreasing function, and also the change is decreasing as well. That means the change has to get smaller. So what's our change the first time around? We subtracted 4. That means to get to the h of 5, we have to subtract more than 4. Well, let's subtract 6. That means that we were going to do 20 minus 6, or 14. That's one possible answer. We could have subtracted 5. That would have been fine, which would mean our answer would be 15. We could not subtract 4, though. 16 is not a good answer. Okay. The reason being is that that means our change did not change, and we know that our change is decreasing. Let me give you a quick alternate way of looking at this. We know that our function is decreasing because the first derivative is negative. We also know our function is concave down because our second derivative is negative. If I were to graph a function which is decreasing and concave down, it seems to me that it would be looking like so. Right? Well, let's punch in some values. We know that at when x is 3, the function is 24. Right? So here's 3 and there's 24. When h is 4, we're only up 20. So here's 4. Right? Now we're only up 20. So this is 24 and this is 20. Now if I go the same distance, that means that 5 is going to be right around there. Look at how high 5 is. Okay? It's not, the distance from 24 to 20 is smaller than the distance from 20 to whatever f of 5 is. We need a number which is lower than 16. It cannot be these two, this range and this range right here are not the same. So there's a picture, there's the concavity, how we are decreasing faster, and it's all because of that negative second derivative.